Bismillahirrahmanirrahim. Assalamualaikum. So today we are going to explain our project for computer organization and architecture subject. Okay, my name is Fatima Azikrin binti Saranizam, and the others are Nur Amirani binti Muhammad Mazdan and Nur Idrina binti Cik Muhammad Zulkifli. We are from section 2 and our beloved lecturer is Dr. Zuriyahati binti Muhammad Yunus. So for this project, we have to build a program, which is we have to convert 4-digit hexadecimal to its 2's complement. Okay, so let's go see the code. Okay, for the data, for this first 7, it is for user prompt, which is to give instruction or the information to the user, and these 2 is the variables. Okay, these 2 are variables to hold the value either from the user input or and the result after converting the digit. Okay, so let we start debugging. This part we're going to know the validity of the input, either it is valid or not. Okay, so I will use this step over to know the validity. And then let's start. And then this is from the prompt user, so we read the first character, so we use A, and then we move, and then second input I will choose N. So the third input I will choose 0, and then the fourth input I will choose B, and then we will move to the next. Okay, so after receive all the value, so we will go to check the validity of the input. Okay, so we're going to start with the first, which is A. So we'll do the comparison. Okay, so for this one, it is for the number, which is if the input is number, we will compare with this one. So 30 is represent to 0 in ASCII, while 39 represent 9 in ASCII. Okay, so this is the ASCII value for 0 and 1 and 9. Okay, since A is 61, so it's greater than 30 and 39. Okay, so proceed. It will jump to upper. Okay, so for the upper, it is to test the character, which is either the input is capital letter or not. Okay, so 41 is capital letter for A and 46 is capital letter for F. Okay, so proceed. Since it's bigger, so going to lower. Okay, so in this one you can see that this is for the lowercase letter for A and F. Okay, then we go this, and then we go to the next section, which is to converting. So this we will explain later. Okay, so this one, we're going to the part which is it loop again to test the second value. Okay, so now we can see that N, we will test the N, which is 6A. So for sure it's greater than this one. Okay, so we proceed, then we proceed to the upper, still greater than those 2 numbers, and then greater than those 2 numbers too. So we will jump above error, which is it will prompt user that the number they insert one of the input is error, so they have to key in back the number. So we try again, so the prompt user try again. Okay, so that's all for the first part.
Hi and Assalamualaikum. My name is Nur Irdina and I am going to continue to explain part 2. Part 2 starts here, which is a loop name digit. In this loop, it is going to convert the characters that user has keyed in into its digit value. So what does that mean? It means that I'm going to show the ASCII code table. When user first key in the input, it is in the range character, which is all of this, because we wrote read char, so it is going to read the input as character. What are we going to do is convert these characters that user has keyed in into its digit value, which is in hexadecimal range, which is only from 0 to 9 and from A to F for alphabet. So that is what we are going to do in this loop. I have already run this project and I started without debugging, and I have already entered 4 characters, which is A3C0. So because this program stored these characters in an array, it will read the characters one by one. So when we first run the program, it will read the first character in here, which is the capital letter A. So to convert the characters into their digit value, we first have to subtract the value in register BL, where it stored the character with 30 hexadecimal. Before that, we have to see here in autos, the capital letter A as a character is equivalent to 41 hexadecimal, like here. So when we first run this line of code in the loop digit, we can see that the value now becomes 11 hexadecimal and the character becomes this empty box, which means that there is no character exists that is equivalent to 11 hexadecimal. As we can see in this ASCII code table, 11 hexadecimal does not have any character that is equivalent to it. So that is what happened. Next, when we have already subtracted the value with 30 hexadecimal, we are going to compare it with 09 hexadecimal to see if it is a numbers as digit value. So because the capital letter A that user has keyed in just now is not a number, it should skip this line of code. And plus the value is 11 hexadecimal, so it is obvious that it is not below or equal to 09 hexadecimal. So we run the next line of code. It is going to jump to the next, which is here, if it is below or equal to 09 hexadecimal. So we can see that it skips this line of code because 11 is not below or equal to 09 hexadecimal. Instead, it is above 09 hexadecimal. So what we are going to do next is subtract it with 07 hexadecimal. 11 hexadecimal subtract with 07 hexadecimal, it becomes the alphabet A. So this alphabet A means that it is in hexadecimal range of alphabet. Just now it is this character of A, but now it is this alphabet in hexadecimal range. That is what happened, and that is how this loop works in converting the characters into its digit value. So we are now going to compare the value with 0fh. If the value is below or equal to 0fh, it will jump to the loop next, but otherwise it will subtract it with 20 hexadecimal. So we can see that it jumps straight away to loop next because the new value is the letter A. So A is below from 0fh, so that is why it runs this code and it jumps to loop next. So next we are going to see what loop next does. In loop next, it is going to convert the digit value of the characters into its 2's complement. So now that the characters are in hexadecimal value, we can easily convert it to hexadecimal 2's complement. So the method that we chose to do is actually subtracting each character from 0f hexadecimal. But we found out that it is quite difficult to do that. That is why we first negate the character and then we add the character with 0fh, and that is actually equivalent to 0fh minus the character. So when we first go into this loop, we negate the character in the register BL. Now it is character A, and when we negate it, it becomes this character F6 something something. So this is actually the negative value of the A letter just now. So now we are going to add this with 0fh. So that will be equivalent to 0fh minus the character. So when we add it with 0fh, it becomes 5 hexadecimal. So that is actually the 2's complement of the character. It's not the 2's complement of the whole string yet. So now we are going to compare the value with 09 hexadecimal, because we are going to convert the digit value into its character value back, because we are going to display it as a character after this. So we first compare it with 09 hexadecimal, and if it is below or equal to 09 hexadecimal, then we have to go to digit to char loop to convert it back to the character value. So because the value is now 5 hexadecimal, so it should jump to digit to char loop. So now it has jumped to digit to char loop. In this loop, it is going to add the character with 30 hexadecimal, because that is the way to convert it back to a character. So we are going to see in autos, now it is 5 hexadecimal, and at 30 hexadecimal, it will be 35 hexadecimal. So 35 hexadecimal is equivalent to 5 in character. As we can see here, 5 character is equivalent to 35 hexadecimal. So when we display it later, it will display 5 as a character. In this loop next one, it is going to start all the program again to read all 4 characters. So I'm going to go ahead and run all the part first until we go back to our digit loop. Okay, so now it has arrived again in the digit loop. And the program is reading the second character in the array, which is 3, which is equivalent to 33 hexadecimal, as we can see here, 33. So we are going to convert the character 3 into the hexadecimal 3, which is this one. So first we subtract it with 30 hexadecimal. So when we subtract the 33 with 30 hexadecimal, it becomes 3 hexadecimal, and there is no character that is equivalent to 3 hexadecimal. So we now have to compare it with 9 hexadecimal to see if it is in the number range in hexadecimal. So because 3 is below than 09 hexadecimal, it will jump to loop next. So yes, it goes straight to next, and we are going to do the same process again to convert it to its 2's complement. So we first negate the value, so it becomes this value, and then we add the number with 0f hexadecimal. Now it becomes this value, so we compare it with 09 hexadecimal, and if it is below or equal to 09 hexadecimal, that means it has converted into its digit value, but if not, then it will go. So because this value is obviously not below or equal to 09 hexadecimal, so it will not jump to digit to char loop. So we can see, yes, it goes to this line of code, which is to add BL with 37 hexadecimal. So this value will be added with 37 hexadecimal. So the value now becomes 43 hexadecimal, which is equivalent to the character C. So this is the 2's complement of the character 3 that we have input just now. Now that it has already have a character value, it will jump straight to the loop next one. So in this next one, it will go again to the starting point of our program. And before that, I'm going to explain it will going to compare the loop counter with 1, because we are going to do something additional to the last value in the array, which is when the ECX is 1. It will go to the loop named last. So I'm going to run until it goes to the last value in the array. Okay, so I have already run the program until it reached the last value of the array, which is in the input is 0, but when we have converted it to its 2's complement, it becomes the character F, which is equivalent to 46 hexadecimal. So now that the ECX is 1, we can see here ECX is 1. It will go to the loop named last. So we're going to see that. So in this loop, we are going to add the last value in the array with 1 hexadecimal, because that is the way to complete the process of converting the numbers into its 2's complement. So that is why we only do this loop for the last value in the array. So the value is now F in character and 46 hexadecimal. So we first add it with 01 hexadecimal. So just now it was 46 hexadecimal, and now that we have added it with 01 hexadecimal, it becomes 47 hexadecimal, and that is equivalent to G in character. So what I'm going to show it is G character does not exist in hexadecimal range. So it actually means that a carry has propagated. So when a carry has propagated, if it is in hexadecimal value, the last value in the array should be 0, and then it will carry 1 to the value before the last value. But since we have already converted all the characters, just now we have converted it into their hexadecimal value, and after that we have converted it back into their character value. So that is why it becomes G character, or 47 hexadecimal. So that is what is different in this program, but that is not a problem, because we can always solve it by comparing it with 47 hexadecimal. So if it is equal to 47 hexadecimal, it means that the character is G, which does not exist in hexadecimal range, so it will jump straight to a loop named carry. It is designed specifically if the number has a carry propagated. So we run this line of code, it will go straight to the carry loop. So when we go into this carry loop, we first display a message that says message carry propagation has occurred, but only 4 characters will be displayed, because if all the numbers has a carry propagated, it should be 5 characters that will be displayed, but in this program we are going to just display 4 characters. So after we display the message, we are going to go ahead and we enter this loop named carry1. So now that the last value in the array is this value 47 hexadecimal and G character, and in hexadecimal, if the value, especially if it is F hexadecimal, if it is added with 1, it will become 0, and it will carry 1 to the value before it. So we are going to make this G becomes 0 character. That is why we are going to subtract the character with 17 hexadecimal. So we can see when we subtract it with 17 hexadecimal, it becomes 0 in character, which is equivalent to 30 hexadecimal, but that doesn't matter because it is now in character value. So that value we are going to store in our array, which is to store the modified characters. So now we are going to decrease ESI because we are now pointing to the last value in the array. That is why we are going to decrease ESI so that it will point to the value before the last value in the array. So we decrease ESI. Now ESI becomes should be 3. So we compare ESI with 0. If ESI is 0, it means that it has already accessed all 4 characters. If it is equal to 0, it will go straight to display. But if it is not 0, then it will go to the value before the last value, which is the second last value in the array. So just now we have already converted the last value in the array becomes 0, and then we actually should carry 1 into the value before the last value. So how are we going to do that? We first access the second last value and we move into the register VL, and then we are going to add 1 hexadecimal. So this 1 hexadecimal is equivalent to the carry that we have from the last value just now. So that is why we are going to add the second last value with 01 hexadecimal, and then we move the value into the array again because we have modified it, and then we compare the second last value in the array with 47 hexadecimal. This is to see if the second last value also has a carry or not. So if the value is equal to 47 hexadecimal, it means that a carry has propagated again. And if carry has propagated again, it means that the value will be equal to 47 hexadecimal. It will jump again to carry 1, which is to subtract it back with 17 hexadecimal to convert it into the character 0, and then we are going to decrease the ESI and point to the value before the second last value, which is the second value in the array, and then we are going to add 1 as a carry, and then we are going to compare it again and so on until it goes to the first value in the array. But the second last value, when we add with 01 hexadecimal, we can see that the value is 34 hexadecimal, which is equivalent to 4 in character. So it is not equal to 47 hexadecimal, and that means that there is no carry propagation occurred. So that is why it is not going to jump again to carry 1 loop, and it will go straight to display loop, which is going to display all the characters. So yes, it goes to the loop display and it ignores the JE carry 1 because there is no carry propagated for the second last value in the array. So I'm going to show the final output that is affected by this carry loop. I'm going to start without debugging again, and I'm going to enter a character which will cause a carry to propagate. So for example, I enter A3C0. So we can see that the 2's complement is 5C40. In here we can see that the 0, when we convert it into its 2's complement, it becomes F, the character F or the hexadecimal F. So when we add F with 1, it becomes 0, and then it has 1 carry, and it will go to the value before it to add the value with the carry 1. For example, here C, when it is converted to its 2's complement, it will become 3, actually 3. So because the value after it has a carry propagated, so the 3 just now will be added with the carry, which is 1 hexadecimal. That is why it becomes 4 in character. So we are going to see what happened if all of these characters has a carry propagate. So we are going to try again, and let's say we enter 0000. So we can see that the 2's complement of hexadecimal is 0000, but it displays a message which says carry propagation has occurred, but only 4 characters will be displayed. What happened here is when we convert 0000 to its 2's complement, it will become FFFF. So when we add 1 to the last value in the array, it actually becomes G in character, but that doesn't exist in hexadecimal. So in hexadecimal, when we add F with 1, it becomes 0, and it has a carry which will be bring to the value before that, and because the value is also F, and then it will be added with 1, it also becomes 0, and it bring a carry to the forward, and this also will become 0 and will bring the carry forward, and the first value is also F, and when we add with 1, it also becomes 0 and actually has a carry that will be bring forward, which is to the value before this value in the array. But we are going to display only 4 characters, that is why the result becomes 0000. So that is for part 2. Thank you.
Okay, so we explain about the part 3, which is start from here, display. Okay, then for this one, move ECX with 4, then new line, then move offset status 2 into EDX, which is the address of status 2, then call write string. This one we will display the status 2, then move offset num hex into EDI. We move the address of num hex into EDI. Okay, then the result one is move EDI into AL. This one we move the value that is inside EDI into AL. Then we call write child, which is display the character inside AL. Then increment EDI, which is the value of index here. Then loop result one. Okay. This one we will look again result 1. Then move offset status 3 into EDX, which is the address of status 3. Then call write string, we will display the status 3. Then move 4 into ECX, move offset new hex into ECI. We will move the address of move value of new hex into ECI, the new value. Then result 2, we will move ESI into AL, which is the value of ESI. Then call write char, we will display the character inside AL, increment ESI, then loop again, result 2. Then new line. So this is for try again. This is if user want to enter new value. Okay, so we will move status 4, offset status 4 into EDX, then call write string, we will display the status 4, then call read char, this is for user to enter the character. Then call write char, we will display the character entered by user. Then new line, then we will compare AL with 79 hexa, which is 79 hexa is the value for y. Then if it's equal, then we will jump into start again, which is the process which we will start the program again. Then if not, then we will compare AL with 59H, which is the value for capital Y. Then if it's equal, then we will jump into start again. If not, we will compare AL with 6E hexa, which is the character for n, which means no. So if it's equal, we will proceed to out. Then if not, we will compare AL with 4E hexa, which is the value for character capital N. If it's equal, then jump straight to out. If not, we will proceed with the error, which is status 5. We will move into EDX, then display call write string. We will display the error message. Then we will jump to try again, which is we will proceed to ask the user the same question, whether they want to try again or not. Okay, so if user enter character other than Y and N, we will jump into try again. Okay, so if no, then we will jump into out, then the program will end. Okay, so that's all from me. Thank you. Okay, so we will try to run the program. So enter the value. Okay, so this is the 2's complement of 381. Then this is the question, whether the user want to try again or not. So at first we try Y, okay, then we will enter a new value. Okay, so then if we, for the try again question, if we enter value other than Y and N, it will print an error message. Okay, so let's try. I enter T, then error message, U error message, then N. Okay, then it will, the program will end. Okay, that's all. Thank you.